Thanks for tuning in to the Red Pill Analytics YouTube channel, where you can choose to see data differently. My name is Stuart Bryson. I'm an owner and co-founder of Red Pill Analytics. There's some additional information about me, including social media avenues, in case you're interested in checking any of those out. This video is about Checkmate. Checkmate is our continuous integration and delivery framework that we've developed at Red Pill Analytics. And in this video, we're specifically talking about our Oracle Business Intelligence, or OBIEE plugin to Checkmate. There's a few videos already recorded in this series. The first video is called The Journey to Source Control, and that video shows you how to use our Checkmate GUI app to onboard an OBIEE project into a Git source control repository. The second video talks about building and publishing OBIEE artifacts, where we talk about using both the Checkmate GUI app as well as back-end continuous integration processes to build and publish artifacts. We also have the third video, which talks about using the Checkmate GUI app to do multi-user development in a new and improved way, and a more modern approach to using multi-user development in OBIEE. In this video, we'll be talking more about the continuous integration aspect that Checkmate enables for Oracle Business Intelligence projects. We'll be taking a look at how Jenkins figures into the equation. We'll also be looking at this from a GitHub specific perspective. We obviously support Git in a lot of different flavors, but GitHub is the platform that most of our customers use, and that's the platform that we'll be highlighting in this video. So this is our high-level Checkmate architecture, and we've drawn this slide over the last several tutorial videos. We're going to look further into the publishing aspect that Checkmate provides, and you can see that we can publish to in this case, Maven, but also pull that content from Maven where we need to, and we'll see how Checkmate does that. But also in the publication, we'll see how we can publish to Jenkins jobs as artifacts, and also we'll see how we can publish artifacts to GitHub. Checkmate handles that for us. We'll also take a look at the role the OBIEE build server plays. So the build server is just a running installation of Oracle Business Intelligence that's there for us to regression test against, to build and test deployments, etc. And we'll see how those things factor into the overall process flow. We'll now take a look at how to design a continuous integration process that's being driven by Checkmate and Jenkins. So we'll take a look at the Checkmate build file, the main point of configuration for Checkmate itself. We'll also have a look at the Jenkins configuration, some of the options available in the Jenkins web UI. And finally, we'll have a look at a Jenkins Pipeline file, or what's sometimes referred to as the Jenkins file. And this is a way for us to design Jenkins pipelines as code instead of as functionality embedded inside the web UI. So this is our Checkmate build file. This is a pared down build file. There's a lot of other options we haven't enabled here that we might use in a production implementation, but for simplicity's sake, we'll just be taking a look at a few of the most common used configurations. So first we have to apply the Checkmate plugin that we're interested in using in this build. And so in this case, we're using the OBI plugin to Checkmate. Next, we'll take a look at the dependencies closure. So the dependencies closure allows us to declare jar files, zip files, etc. that are necessary for us to use in this build. So in this case, we're using our built-in OBI regression testing capability, but you can see there commented out we also support Oracle BVT, but we're just using our built-in jar file for regression testing, the Checkmate jar file. You can also see that we've declared dependencies on some prior builds from OBI. So as you saw in one of the previous videos, we're able to publish zipped up content, zip files containing repository and catalog content from prior builds, and we're able to declare those as dependencies in this build. So for instance, you see the feature build group, which has a plus next to the version, meaning that we're going to use those tasks to regression test our feature branches. And by putting that plus there, we just simply want the most recent version of code that's been built and deployed to Maven. So whatever the most recent version of code is, that's what we'll pull down anytime we use any of the feature tasks that Checkmate provides. You can also see the release build group, which declares a static version of code. So that's for testing release branches. So usually whatever version you declare there is the version that's in production or in QA or whatever you want to test against, a release that you want to test against for subsequent releases. And then we also have the promote build group, which is a build group we use for deploying to downstream environments or promoting. And in this case, whatever version we're building is the version that will be promoted downstream, thus the project.version declaration. Hopefully that's clear. Moving down to where we declare our analytics capabilities. So Checkmate is able to stream results from builds, regression tests, metadata changes, etc. We're able to stream that to a variety of technologies. In this case, we've declared two. We're using Redshift, and we're loading that via AWS Firehose. So we're configuring that in a closure. We also have the direct analytics stream declared, and that's just a direct upload to AWS. We also support Google BigQuery via Google PubSub, and we also support Elasticsearch, and we support the Oracle database, of course. Here we're declaring our regression test groups. So it's a named group with a catalog folder that goes along with it. So in this case, anytime we call any of the regression test group tasks for regression testing, we're going to test all of the analyses in the shared/regression folder. So that gives us the ability to declare one or more test groups to be able to use however we see fit. And also within each test group, the library folder parameter can accept a colon separated list of catalog folders. So you can test as many different catalog folders in any sort of collection of test groups. So it's really a highly configurable way to do regression testing. But in this case, we're just simply going to run regression tests for any analyses that are in that shared/regression folder. And finally, we just need to tell Checkmate a little bit about our OBI environment. So we need to tell it where the middleware home is. For 12c specifically, we need to tell it where the domain home is. We have a compatibility flag, so Checkmate is able to work in 11.117, 11.119, and all the different versions of 12. And the APIs that exist in OBI that Checkmate interfaces with change throughout all those different versions. There's a lot of different ways to upload repositories, publish catalogs, etc. And so that compatibility flag just is a way for us to support all those different APIs. Sometimes the differences are subtle, but sometimes they're quite different, specifically from, say, 11 to 12. So that's just a way for us to tell Checkmate how to interface with those APIs. And finally, we have the publish bar parameter. So this is a 12c specific capability for us to, anytime we're publishing artifacts, we can choose to also build the bar file and publish the bar file. And the only reason that's not on by default is it does take quite a bit of time in the 12C APIs to actually build a bar file, several minutes usually. So this is just an easy way for you to bypass that if you're not currently using the bar file. Now we'll take a look at the Jenkins configuration. As I mentioned previously, there's not as much that we have to do in the Jenkins UI as we used to in previous versions, but there are a few things we still need to configure there. So let's take a look at the branches that we want to build. So we're only listening to the develop branch and the master branch. Those are the only two that we're interested in. So feature branches we test a little bit differently. So let's see how that's done. So instead of listening for feature branches are those branches where developers are actually doing work and pushing those branches which are specific to a particular feature. So some piece of work that needs to be done is built as a local feature branch and pushed to the server. Jenkins isn't currently listening for those feature branches. Now we could enable that if we wanted to, but Jenkins gives us capabilities to do this in a little bit better way. And as you can see there, instead of building the origin branches for feature branches, we're instead going to build pull requests. So this gives the developer the ability to work in an isolated feature branch, push their code changes to the server without causing a build. So that gives us the ability to develop throughout the day, pushing our changes to the server without initiating a build. In this case, the testing and building of feature branches is only caused by the opening of a pull request associated with that branch. So you can see build origin PRs merged or build origin PRs unmerged. And what that means is we've chosen to build the merged with the base branch. And what that means is when we open that pull request, before any building and testing occurs, Jenkins will actually merge the feature branch in with, in this case, the develop branch prior to doing the regression testing. It doesn't commit that merge. It just performs the merge to make sure that whatever branch that we're testing does successfully merge into the develop branch or the master branch, whatever your base branch is. So that's a really handy way for a developer to test that their code is completely mergeable and completely viable. So now let's take a look at the Jenkins file or the Jenkins pipeline file. Now, slight warning here, this is perhaps the more techie of the three, or the most techie of the three. So, if you can't quite stomach that, then maybe you can fast forward through it. But for those of you that are interested in understanding how the new Jenkins pipeline functionality works and how it would be applicable to an OBI project, then stay with us for this. So first, we're able to declare multiple stages in our Jenkins file. And you'll see when I do the demo how you can visualize that in the Jenkins UI. But we declare a series of stages and the tasks or processes that we want to run as part of those stages. So first and foremost, in the build artifact stage, we want to check out our Git repository, and it will check out whatever branch we're currently executing against. Now we've declared a parallel series of steps. These things will run concurrently. In this parallel step, we're doing a startup of Oracle Business Intelligence. In 12C, if you call the start.shell script, it only starts components that aren't currently running. And if they're already running, it just leaves them alone. So it's a safe step in the process to put just to ensure that Oracle Business Intelligence is up and running. While we're running that, we're also building our content so that we don't lose any time, or so that we can run as efficiently as possible while we're either starting Oracle Business Intelligence or testing to see if it's started. We're also building all of our content. So notice we're calling the feature compare checkmate task. And what that does is it pulls down the feature content, so whatever we've declared as the feature content in Maven. Remember that we had a plus sign there, so that's whatever the most recent build that was successfully deployed to Maven, that's what we're going to pull down. So we're going to pull down that zip file, which has the repository and catalog in it, and we're going to unzip it. So we have the previous version of content. We're going to build the most recent content from the Git source repository that we just checked out. And then we're also going to build the incremental patches that represent the delta between those two versions. So at the end of this stage, we have OBIE up and running. We also have our prior version of OBI content, both the repository and the catalog. We have our most recent or current content that we built by checking out Git. And then we also have the incremental patches for both the repository and the catalog that represent the delta between those two versions. So we're in a really good spot at this point in the pipeline to be able to regression test thoroughly our most recent build of OBI. The next stage that we have is called Prepare Elastic Instance. Now, if you're running a constant version of Oracle Business Intelligence to regression test against, which most of our on-prem customers are doing, this stage probably wouldn't be there. But this stage is specific to our cloud offering with our hosted customers because we have a lot of different images of Oracle Business Intelligence that might spin up to satisfy this build. We have to do a few things to prepare it. And so without going into the details, we're just preparing an Elastic instance, which has been spun up and had no content. We're just sort of seeding that instance so that it can satisfy this build. The next stage is called our baseline tests. So we're calling the feature baseline workflow, which is a Checkmate task from the CLI. And what that means is notice the feature name in the task. And what that's going to do is upload all of the prior version of Oracle Business Intelligence content, upload that to the build server, and run all of our regression tests, saving the results of those tests as well as the logical SQL and the physical SQL out to a series of files. So at the end of this, we've got our current content sitting in Oracle Business Intelligence, plus we've run through all the regression tests that we've declared, gotten the results, and saved those results. The next stage is called the revision test stage. And in this stage, we upload the current content or whatever we built from the Git repository. We upload that. We handle the connection pools. So we export out the connection pools and import them back in as part of the process. And then we run all of those same regression tests against the current version of content. So at the end of this, we've run through a series of analyses from Oracle Business Intelligence for a prior version of content as well as for the most recent version of content. And we have all of the results of those tests saved out. And then the next stage is called compile tests, and this is a purely Jenkins step. So Checkmate generates what's called JUnit files. Those are XML files as part of the regression testing framework. And these files are a sort of industry standard way of declaring a regression test and its results. So what we're doing here is telling Jenkins where to go find those regression test result files. It'll both be for the baseline and the revision. And so at this stage, Jenkins is aware of which regression tests have failed, which have been successful, and it will actually pause the build at this point if we have failed regression tests. Now we're moving into the publish artifact stage. And so we've got a little bit of conditional logic here where we're checking to see if we're currently running against the master branch. If this build is executing because of a commit to the master branch, then we're actually going to cause a new release to be created. And Checkmate handles that. So there's a lot of options to that, but in general, just imagine going from 1.0 to 1.0.1, etc. There's a lot of parameters that we can pass as to how to increment the version number. But in general, just understand that we're creating a new version inside of Checkmate. We're going to clean up our distribution directory to make sure that we're only publishing content that's been built as part of this release and not content that was built in a prior release. So we're cleaning that up. We're building our zip files, perhaps our bar file if we've got that enabled, and we're publishing that to Maven. We're also going to publish our artifacts back to Jenkins, and that's what this step is describing. So when you go into a Jenkins job, if you want to see all of the artifacts that were built as part of that job in an easy single point of access UI, then we'll be able to download those zip files from Jenkins itself. So we're just simply taking those same distribution files that we published to Maven and also publishing them, so to speak, to Jenkins as well. And then finally, again, if we're on the master branch, we've configured a release. We also want to upload to GitHub any artifacts associated with that release. So GitHub is not only a place to store your source control, it's also a place that you can store your built artifacts. Those are uploaded as part of a release. Series of REST APIs that enable that, and Checkmate is plugged into how to do that. So if we have declared a new release, we need to upload the artifacts to GitHub as well. So at the end of this, we've got our built artifacts published to actually 3 places. And finally, really the last step is to process our analytics files. So throughout a build, Checkmate is generating a whole series of JSON files that capture the results of the build. So all of the successful and not so successful tasks that executed, the successful and not so successful regression tests that have been executed, and all of our metadata changes. So Checkmate, using the diff files that we generate, are able to compile a list of all of the metadata changes that have occurred. We stream all of that to any of the analytics platforms that we've declared in our build script. So now let's dive in and take a look at how this actually works in practice. Here we are inside of GitHub, and this is the main page for our project called MetaCortex. And that's the same project that we've been working with in all of these Checkmate tutorial videos. You can see we have a couple of branches, so let's take a peek at those branches. If you recall from the previous video, we had 2 feature branches we were working on. One was MTCX9, and that's where we created a new fact measure, and then MTCX10, where we created a new dimensional measure. And in both branches, we also created catalog reports to go along with those new attributes and measures. You can see I've gone ahead and opened a pull request for MTCX9. That pull request is open, and that pull request is successful. So we're going to walk through the process of what that looks like we're going to do that for MTCX10 and see what it means to open a pull request, to check the status of the regression tests against that pull request, check the status of the build that's also going on for that pull request. So we'll click new pull request right there. For the purposes of these videos, we're merging right into master. You might have a intermediate branch called develop. There's a lot of pros and cons to both approaches. We're merging straight into master. So we're going to open the pull request to have MTCX10 merge into master. Now, by creating this pull request, we're not actually merging it. That process will occur downstream. All we're doing is, this would be the developer opening this pull request to let the source master or whoever's managing the project know that this particular issue has been completed. So now that we've given our pull request time to build, we can see that all the checks show as successful. We also show that this branch could easily be merged. We can merge the pull request and merge in our new content to the master branch simply by pushing this button. We can also take a look and show our checks, and that is we can see our continuous integration process from Jenkins running, and it tells us that build and as well as the associated regression tests were all successful. So let's go take a closer look at that. So back here on the main screen for the pull request build, we can see that we have these high-level tabs where we can take a look at some of the different aspects of the build. We can take a look at the regression test tab where we see all of our regression tests were successful. Now, one negative about this new Jenkins UI, although it looks great, it doesn't have the capability to drill into successful regression tests. If there were failed regression tests in this UI, we'd be able to have a look at them. But since everything was successful, there's really no ability to click in here. We can still go to the traditional Jenkins UI and have a look at successful regression tests. So we can see we have our baseline execution. That's the execution of the prior version of OBI content. We have our revision execution, which is the execution of the new content that we're trying to regression test. And then we also have our compare step. So we can drill into any of these and see that all of these analyses executed successfully in the baseline execution. They executed successfully in the revision phase of the execution. And then we can also take a look at the compare step. So this is where we're comparing. In this case, we've got a few of the tests disabled, but we're comparing a hash value of the results of the analysis. That's the actual data that's been generated in the report. We compared a hash value of those. We skipped the full text comparison just for speed, but we could enable those pretty easily. And we're also comparing the logical SQL comparison. Jumping back to the new Jenkins UI, we also have the ability to see our artifacts. So here are the artifacts that we built as part of this build. And you can see, don't be too concerned with the snapshot notation. That's just a Maven approach to distinguishing between full release distribution files and those distribution files that were built in a non-release branch. So in this case, we're running a pull request, so these are not fit for distribution, and the snapshot clearly designates that. We have our bar file, so this is a traditional 12C bar file, no magic going on there. We just generate the bar file and publish it to Maven. But we also have what's called our build distribution file and our deploy distribution file. The deploy distribution file has everything that the build distribution file has in it, but it also has the additional patch file. So let's take a look at that distribution file. Here is the contents of our distribution file. So we have a catalog section and a repository section. If we look at the catalog section, we see that we have the full catalog from our current build. So that's basically what was in the GitHub repository that we checked out. We also have an archive file of the current catalog. So that's a full archive file of the shared folders. We also have the full catalog that we pulled down from Maven. So that's the previous version. And an archive file of that as well. But we also have our diff files. So we have a diff file that represents the difference between those two versions. And we also have what we call the undiff file. So that's a rollback patch. So we generate rollback incremental patches as well as the promote incremental patches. And we can take a look at one of those pretty quickly. Probably won't make a whole lot of sense to you. These diff files are managed by Catalog Manager, either the command line utility, well, just the command line utility. These are applied using Catalog Manager. But we can see that we have the patch file only contains our new report, which is the calculated tier report. So going back to our file system, we can see from a repository perspective, we have our full version of the current repository. We have a full version of the prior version of the repository, the one that was pulled down from Maven. And then we also have our incremental patches, and a CSV file that lists all the different changes. So if we take a look at that CSV file, We can see the items that are included in that patch file. So if you're interested in what's in the patch file, it's a little bit easier to see that here. And then we can see the actual patch file. So the patch file contains only, you notice the calculated tier and the information necessary for applying that metadata content to a downstream environment. So until next time, thanks again for tuning in to the Red Pill Analytics YouTube channel, where you can choose to see data differently.